Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at the structure and the properties of carboxylic acid. If you remember in the previous video, I have actually told you how you can actually use the parent hydrocarbon like methane, ethane and propane. You can use them to predict the name of the alcohol, which is going to do the same thing with the carboxylic acid. The functional group in carboxylic acid is COOH. So whenever you see COOH group with any molecule, they are called as carboxylic acid. Now, you have three examples there, 1, 2, 3. I'm just going to name them first and then I'm going to show you the display formula. Now, how you need to predict based on this CH3, a lot of people actually make a mistake. They just say, oh, it's methanoic acid. You don't actually do that. You actually look at the total number of carbon atoms. Methane has only one carbon atom and ethane has two. So anything start with METH will have one carbon atom, and anything which has two carbon atoms in the whole molecule will be starting with ethane or eth. Now here you have two carbon atoms, so you count the number of carbon atoms 1, 2, so it is actually ethane. Now based on the parent molecule, which is C2H6, if you remember. So C2H6 is ethane, so you write down the name as it is. Now when you see, because there is one hydrogen, the whole molecule is actually replaced by the COOH, you can remove this E, so you can say ethanoic acid. So you just remove E like alcohol and you put oic acid, and that will be ethanoic acid. Then you go to the second one, 1, 2, 3. Don't worry about the number of hydrogen like in propane. 1, 2, 3, 3 carbon atoms. The parent name is propane. So you write down propane as it is, and then because of COOH, you have to remove this and put oic acid. So that will be the name of this molecule, propanoic acid. Then you look at the third one, 1, 2, 3, 3 carbon atoms, and this one as well. You count this carbon as well. So 4 carbon atoms, and that will be butane, 4 carbon atoms. You replace E, you put oic acid, and it will be called as butanoic acid. So that's how you're going to name them. Let's talk about how you can actually write down the display formula of ethanoic acid. Look at the display formula first. CH3 means you draw 2 carbon atoms. That's the technique you're going to use. You draw all the 4 carbon atoms as it is. You draw a line between the carbon atoms no matter whatsoever. Then you will have COOH there. This COOH means that this carbon atom is doubly bonded with the oxygen, and then it is bonded with the OH on the other side. So this COOH actually is written like that. This carbon atom will have 3 hydrogens, so I will write down 3 hydrogens on this carbon atom. Now carbon belongs to the 4th group. It can have maximum of 4 bonds, so let's count it. 1, 2, 3, 4, 4 bonds. This carbon atom 1, 2, 3, 4, because this double bond will be counted as 2 covalent bonds. Now propanoic acid, 1, 2, 3, 3 carbon atoms, so I will actually draw 3 carbon atoms as it is. I will convert the last one again as COOH, and rest of them I will just complete the hydrogen 1, 2, 3 and 1 there. So if C2H5, you can count that if 5 hydrogens, 1, 2, 3, 4, 5, and that is propanoic acid. Let's do the third one, which is 3 plus 4, because this carbon will be also counted as. You write down the 4 carbon atoms, you convert the last one into COOH, and rest of them you just draw the lines and you complete the hydrogen on that. Please be careful, do not put a line underneath this carbon atom, otherwise this carbon atom will have 5 bonds. So that is actually incorrect structure if you try to put a hydrogen under C-double-O bond. Now this is a display formula, so when if they ask you to draw a display formula of ethanoic or propanoic or butanoic acid, this is how you're going to draw them. You need to remember how many carbon atoms are there, then it will be a lot easier for you to draw it. Properties. they are soluble in water. So if you actually put any carboxylic acid in there, CH3, COOH, they will be soluble in water. Now when you dissolve in the water, what's going to happen is they will dissociate themselves. So CH3, COOH, which is actually ethanoic acid, when you dissolve that in the water, it does not chemically react with it, but it's just being soluble because of the hydration energy. So this will be broken. Acids are actually called as an acid because they release H positive ion, or they donate a proton or donate H positive ion in the aqueous solution. That's why they are known as an acid. Now this one will be broken from here, so the rest of the molecule will be CH3, COO negative and H positive ion. Now this H positive ion will determine how strong the acid is. Now when they actually make this, if you put the pH paper in there, for example, if you have this is your pH 0 to 6 acidic, and then you have 7 neutral, and 8 to 14 is alkaline or basic. Now the more you are on this side towards 0, the more you are acidic. So if it's 1, 2, it's a strong acid. Whereas if you have any carboxylic acid like this, their pH will around 5 to 6, which is very close to 7. That means they are very, very weak acid. Now what does that mean by weak acid? When you actually dissolve in water, CH3, COOH, CH3, COO negative, H positive ion, and then you have CH3, COOH. Out of these molecules, you can look at this one actually doesn't dissociate itself in the water. Only very tiny amount of the carboxylic acid will dissociate themselves and produce H positive ion. So the majority of the carboxylic acid will stay as carboxylic acid in the water, because the strength of the acid will be determined that how much H positive ion concentration you have in the solution. That's why it is a very weak acid, because it does not actually dissociate completely. So you can say that there's why it produces acidic, because it produces H positive ion, and also it is actually a weak acid as it does not dissociate completely. Reaction with the carbonates. Well, strong acid always produce carbon dioxide when they react with the carbonates, and it is actually quite okay to use this carboxylic acid to do the reaction. Now if you react it with any carbonate, sodium carbonate, calcium carbonate, you will always make salt plus water and carbon dioxide. This is a very famous reaction that any acid like HCl, H2SO4, when they react with any carbonate, they produce water and salt, and along with that they produce carbon dioxide. Now it will happen the same. You will produce the same thing like CH3, COO, just like alcohol, the OH lose a H positive ion and the Na was attached there to make a salt. So the calcium will come here, sorry, not sodium, calcium will attach itself there. It will produce water, H2O plus CO2 gas. So on reaction with the carbonates, carboxylic acid will actually make a salt, water and carbon dioxide. So you need to remember how to predict the names. You remove the metal from the carbonates, you remove the hydrogen from the carboxylic acid. This will attach on the hydrogen, on the oxygen, and HS, you will left with hydrogen and CO3. That will produce water and carbon dioxide. Reaction with oxygen. Now it is not going to combust, or it is not going to burn with oxygen. When you do the oxidation of the alcohol, CH3OH. Now reaction with oxygen, it is not the reaction of carboxylic acid with the oxygen. What I'm trying to say, how can you actually make the carboxylic acid? So the alcohols, when they undergo oxidation, they actually produce carboxylic acids. We can just say C2H5, and they can produce carboxylic acid. And this is how you actually can explain the properties and the structure of carboxylic acid.